Good afternoon, everybody. I am going to talk about a small tool that we built called Test Management Ninja Tool to help with managing UI test flakiness. To set some context, here is just a snapshot of our test results for last 14 days. As you can see, we run a lot of tests in terms of the run and the execution, but these are essentially about 150 tests just being run across several different PRs and several different projects. And you can see there is still some flakiness or failures in the tests. Briefly touch basing on different reasons why the tests actually fail. Most of these were covered in a lot of different talks that you guys attended at the Selenium conference, specifically this category called badly written tests. I'm not going to go into details about this, but some of the additional reasons why tests fail are because of environment issues. For example, build issues, meaning your application was deployed, but it depends on a bunch of assets, but those are missing, and hence your tests fail. There could be some configurations that are required or are specific to an environment that cause the test to fail. And there are, let's say, dependencies that your tests depend on, which are behaving differently in when the tests are being executed that might result in some test failures. The third bucket is essentially the infrastructure issues, where, again, there were a bunch of different talks at the conference which help you address some of these issues around, grid, or if you're using a cloud provider, if you run into some issues with those, browser and OS upgrades as well. Fourth category, which is essentially where we would want our most of our test failures to fall under, is essentially app issues. So if there is an actual bug, then the test is expected to fail. Or if the application changed and there is an update that is needed for the test, then we expect the test to fail in those scenarios as well. So how do we define a life cycle of an automated test? So let's say you write a new test. We want to execute it X amount of time. So in our case, we set it to 40 times. So if a test is executed for 40 times, we look at its pass rate. If the pass rate is above threshold that we have set, in our case, it's 90%. If it is above 90%, then we move it to either a smoke bucket or a regression bucket. And by the way, each of these buckets are defined for each platform, meaning a test could be in desktop Chrome, smoke, whereas the same test could be in regression for a mobile emulator or a mobile browser. Once the tests are in these buckets, if let's say you run into a failure, we look at the pass rate, meaning from last 40 runs. If it is below the threshold that we set, then we immediately move that test into a bucket called test under test. If it is above the threshold that we have set, then the developers would go and manually look at why the test actually failed. Once the test is in that bucket, we create a ticket for it, and then somebody has to go in and actually fix these tests. Managing all of this life cycle for multiple different platforms could be very tedious and error-prone. So what we have done is we have actually automated this whole process of calculating the reliability and moving tests around into different buckets using the APIs. So from a design perspective, this is how the application looks like. We have a bunch of test execution that happens. Then we we send the results for each execution into a data store. So in our case, we use Elk, which is an open source project. Out of the box, it gives us search APIs that we can use to actually query the test results and then calculate the reliability on it based on the exceptions that we get and excluding the exceptions that were in one of those four categories. And then we calculate the reliability. Once the reliability is calculated, we apply the algorithm to move the test between different buckets. So a test, as an example, if a test, as I was explaining earlier, was before in a TUT bucket for desktop Chrome, now it has been fixed and updated and can be actually moved into a stable bucket, either smoke or regression. So from different components perspective, this is how they align themselves. Most of these individual projects are open source, so you should be able to use this. So as a sample output from our TMNT, this is how it looks like. So if you look closely, the new tags that we have for this particular test, which has this UUID on the top, it was moved from the TUT bucket into the regression bucket for mobile emulator in a Chrome, and it was moved into Firefox regression as well from TUT bucket only for Firefox. The tags for the other platforms still remain the same. Takeaways, I hope you have a better understanding of why UI tests fail beyond just badly written tests. Hope you can go back and start measuring and categorizing your test results, and then hopefully you can use the open source tool to move different tests between different buckets.